Okay, here we go. 200 million year old insect color revealed by fossil scales. This goes along with this. Well, this was only 100 million years old, but still. I done this in August 2017. Here we go. It says researchers determine the color of 200 million year old insect? Scientists from China, Germany, and UK have new evidence that reveals the true color of fossil insects. It was recently published in Science Advances. Structural colors have evolved in a myriad of animals and plants and result from the wavelength selective scattering of incident light. I don't know if I'm saying. Such colors are typically more vibrant and visually arresting than those produced via pigmentation and are often multifunctional, playing important roles in intraspecific sexual signaling, however you say that, crypsis, and crypsis. Like, I don't know what those words mean, I'm sorry, but like, predators, hiding from predators and stuff like that too. And also, the insects evolved along with the flower and plant life as well. I think I went over that in this video. I'm not 100%. Anyway, it says, the Lepidoptera exhibit in their scales, that is, like the moths and butterflies there, see, some of the most diverse structural colors produced by insects. This diversity undoubtedly contributed to the evolutionary success of the order, despite sustained interest in the structure, development, and photonic and other biomimetic properties of that genus. Scales in neonatological studies, as well as recent research into structural colors in fossil beetles and feathers. The deep evolutionary history of scales and structural colors in them is poorly understood. And recently, they reported scale architectures from Jurassic Lepidoptera from the UK, Germany, Kazakhstan, and China, along with Tarachoptera, a stem group of Amphiesmenoptera, from mid-Cretaceous Burmese amber. And that, remember this here was in amber as well. I don't remember where it was. I think it may have been the same area this was found. I'm not 100%. Like I said, it's been a while since I've done that video. So they used optical microscopy, scanning electron microscopy, transmission electron microscopy, and confocal laser scanning microscopy to reveal the gross morphology and ultrastructure of the scales. See there. Using the ultrastructural parameters identified in Jurassic specimens, they demonstrated the use of optical modeling to describe the theoretical optical properties of the type 1 bilayer scale arrangement, thus providing the earliest evidence of structural colors in insect fossil record. I'm not going to go more into that stuff. Y'all can read that, but that's pretty interesting stuff there. They can, see the color. It says the findings have broader implications. The leader of the research group says the widespread occurrence of wing scales in Jurassic moths and butterflies and them other insects, since I can't pronounce the word good, strongly suggests that wing scales, including some possibly unknown morphotypes, were widespread in stem, that big long word I can't pronounce again, prior to their apogee in the butterflies and moths. Given the presence of the structural coloration in this basal fossil, the advent of major moths and butterflies by the Cretaceous raises the possibility that this taxonomic radiation may have been accompanied by increased diversity in scale, shape, microstructure, and optical effects. Future studies will characterize the optical response of scale nanostructures in other fossil specimens and will provide evidence for the presence of scale pigments in fossil moths and butterflies in order to inform models of the evolution of structural colors in them. So that's pretty interesting stuff there. And here's a related article. It come from here. This was from 2011. This is before they did that stuff there. It says that this is where they reconstruct them. The level of detail preserved in the moth's fossil is pretty spectacular, they said. Other details of the fossil couldn't be seen, like the colors there, see, like they found here, with that new technology there. Anyway, there's another there. Well, that's the same as that. Anyway. And here is the Nanjing Institute of Geology and Palaeontology, Chinese Academy of Sciences. That's where this research, most of this research was done. And there was the moths. Anyway, and here is the new species there. They discovered. Tarachoptera. This was published late last year. There. Anyway, and here is its family. You know, see here. Amphiesmenoptera. I'm not even gonna try. I'm sorry. It's an insect superorder. And it's got two sister orders, the butterflies and moths, and that Tarachoptera, and they added this group to it too. There's no wiki page for that, but there's this here. As you see, these. Anyway, they ain't much on there. And here's the paper for the findings on this here. If you want to check that out there. Anyway, and that was mentioned in this article as well. Let me see. I'm so sorry. Here you go. However you said that. I'm so sorry. These are extinct. It says, here they are there. Well, they extinct, whatever. Anyway, archaic moths. It's a superfamily of our mandibulate archaic moths, all placed in the single family, containing about 20 living genera. Oh yes, extinct. Anyway, sorry, confuse those two words. Anyway, there ain't much about this there, but there you go. If you want to check this stuff out, and you know, there's that as well. There's some links there too. There, that stuff there. Anywho, there we go. That's all. Just it really fascinates me. You know, it's fascinating. You know, to finally see the colors that these insects were back then. It's probably not so different from today, mate. And well, I would say maybe it is because of the way the light's different now than it was then. You know how that fluctuates and changes. But anyway, y'all, that's all. I'll leave the links below. Y'all check it out. Take care, y'all. Love you. See ya. Thank you, Bella.